Triple integrals in spherical continued. We're going to look at a slightly different surface here, slightly different solid region. Phi goes from 0 to pi over 4. That's a cone. Go all the way around, so it's a whole half cone. Only here, rho starts at 0, goes out to 2 secant phi. So you can at least partially sketch this surface. Okay, we come from 0 down to pi over 4, and then theta goes all the way around. The question is, where does rho stop at? Rho starts here and goes out to some indeterminate surface. Yes, and now we don't know what it is. Well, if you take rho equals 2 secant phi, you can convert that to rectangular by using any of these 7 equations. Well, I don't see any secants up here, but you can rewrite secant in terms of cosine. Rho equals 2 times 1 over cosine phi. Multiply by cosine, you get rho cosine phi equals 2. And guess what rho cosine phi equals? You guessed it, it's z equals 2. What's that? That's the horizontal plane. So guess what? Right there is z equals 2, otherwise known as rho equals 2 secant phi. And so it's a cone. We did order an ice cream cone at Hoover's, and guess what? We ate the ice cream off the surface and we have a flat top. So speaking of Hoover's, we should have another Friday meeting sometime. I will guarantee it, even if we have a snowstorm. Nothing more fun than having an ice cream cone in a snowstorm. So that's the surface. How do we set up the limits? Guess what? Phi goes from 0 to pi over 4, and 0 to 2 pi, and 0 to 2 secant phi. We'll eventually get around to evaluating one of these, but for now we'll just leave them. That's some important points. Easy to integrate. Rho squared d rho is rho cubed over 3 from here to here. You end up with a secant cubed, which is really cosine to the minus 3. And you have cosine sine. You can do it as a u to the minus 3 du. It's the standard integration rules. It's not that difficult. Understanding how these spherical coordinates work, that's the most important part at this point. So, okay, that's our third spherical integral.